All right. Hope you guys are having a great day or night or morning or whenever you're watching this video. Um, so last week and even yesterday, we spent some time on just getting the antiderivative, right? Getting what this function would be. That is a general solution, okay? Meaning that it could be x squared plus 3. It could be x squared minus 4. We don't know what that c value is yet. Okay, today's going to be the first day that we're actually going to have enough information so that we can find out what this actual solution is, what this curve is going to be. So just like last week, we're going to be finding the antiderivative, or we're going to be integrating. All of these, right, y prime, f prime, dy over dx, those all mean that I'm giving you the derivative. And this information applies to what is happening on your original function. Okay, which means I need to find out. I need to integrate to go and get that derivative. I need to integrate that derivative to get my antiderivative. Last week we would have just had this. Okay, this first step of rewriting like this is not necessary. I'm just trying to bridge from last week to where we're going this week. Okay, if I go and use my power rule, that's going to say, well, add 1, that's going to be x to the third. Then I'm going to have 3, it's already there, times 1/3. So this would be what my function will look like. And again, last week is where we would have stopped. But now I know this information. I know that this is my x and that's my y. So go and plug it in. Y is 3, x is 2, so 2 to the third plus c. So I get 3, let me draw an arrow there. So 3 equals 8 plus c. If I go and subtract 8, that makes that minus 5. I do not feel like writing this entire equation again. So I'm going to go put minus 5 where the c used to be. And there's my function. That's my original function. If I went and looked at, again, if you don't like this notation, if you want to go and say, if I go and integrate, now I'm going to have y. If you want to change all of your f of x's into y's, that is fine. Okay. And if I go and integrate there, all right, so I'm going to do there. If I go and integrate, that's going to make that x to the 4/3 multiplied by my reciprocal and times the 4 that was already there. So I can get rid of that. And now I'm saying, well, my original function is 3 x to the 4/3 plus c. And it gave me the notation like this. But again, this just says my x is this and my y is that. So if I go and replace it, I get 50 equals 3 times 8 to the 4/3 plus c. Start with the cube root of 8, that's going to be 2. 2 to the 4th power is going to make that 16. So 50 equals 3 times 16, which is really 48. So c equals 2, because I'd have 50 minus that 48. So that's going to be 2. And again, I'm just going to go back up here, not rewrite the entire function all over again, and just write the plus 2. Just pay attention to my variables. Sorry about that. On this next one, it says dy over dx, which means that I really have an x there. If I'd had this last week, it would have looked like this. Oops. The integral of 8 dx. So that's going to tell me, well, now I have y equals 8x plus c. And again, this just means there's my x and there's my y. So if I replace those, 5 equals 8 times 2 plus c. So 5 equals 16 plus c. Subtract my 16. That's going to make that negative 11. So if I go back up here and replace it, that's going to be minus 11. Okay. This problem looks like what we saw yesterday. If I say, here's my derivative, which is the same thing as writing it like that, just like yesterday, I'm going to go and integrate. So I'm going to have 2x In order to get the cosine of x, I'd have to start with the sine of x. So think about, well, if I start with the sine of x, its derivative is cosine of x. Or make a sheet of paper that has all 6 of those that you need. I'm not going to know what you have. So plus c equals f of x. And again, if you don't like to use f of x, because over here I really have x and y's, call it y. And there's my x, and there's my y. So I'm going to have 1 equals 2 times 0, plus the sine at 0, plus c. So I'm going to have 1 equals 0, plus. Remember that when I go and use my unit circle hands, there's 0. And how many side fingers do I have? 0. Because that's what happens on the right side of my finger I have down. So plus 0 plus c. So that means that c has to be 1. Again, I just go back up here and write plus 1. And this is the part that I would want. And again, you could write f of x there if you don't want y. Or if you even called it this, that would mean the same thing as well. If I went look to my next one. So again, last week we would have seen this. I'm going to rewrite it in a way that's actually helpful to me. If I go and integrate, that's going to be 4. Still going to be there. Add 1 to the top. That's going to make that is going to, you know what? I'll leave it. I'm just going to roll with it. Okay. So then if I multiply by my reciprocal, that's going to be 4/3. And then plus c. And again, if you don't like f of x, call it y. But y is going to equal 16 over 3, x to the 3/4, and then plus c. So now I know that this is my x, and that's my y. So go and replace it. So 7 equals 16 over 3 times 16 to the 3/4 plus c. So the 4th root of 16 is 2. 2 to the 3rd power is 8. So I have 16 times 8, which that should be 7 equals 128 over 3 plus c. Got my plus c there. And then I'm going to subtract that. So 7, which is really 21 over 3, equals c. So just try to change that real fast. So it's going to make that negative 107 over 3. So I just go back up where it says y equals and make that replacement. Oops. So minus 107 over 3. And that's what I'd have there. On the next one, again, if you want to go and change these first, so that you're not looking at function notation, that's fine. Again, when I go and integrate, which is what I'm doing here, I'm becoming y equals. This is going to say use that power rule. Right? Again, I would have seen this last week. And if I add 1, that's going to make that x to the 3rd. 3 times 1/3, oh, just x to the 3rd. If I go and add 1 there, that's going to make that x squared. Negative 2 times 1/2 is going to be minus x squared. And then plus 2x plus c. And then plug in what you know. You know that your y is 3. So 3 equals 1 to the 3rd, or 1, minus 1 to the 2nd. So minus 1 plus 2 times 1, so 2 plus c. So I get 3 equals 2 plus c, which means when I go and subtract 2, that says c is 1. And again, I'm going to be super lazy, and I am not going to go back and rewrite the whole thing. I'm just going to go back and find out where it says y equals and make that replacement. Okay, so if I were trying to go through maybe some steps of how I'm going through and working these, I would, first off, if they give me function notation, if that is still confusing to you, one of my first steps would be take function notation and write as an ordered pair. It means the same thing. If you're like, I can go either way, that step is obviously not for you if it's not helpful. Then from there, I would go and integrate, use my power of integrals, my power rule for integrals, and also might have some of those trig integrals. And again, you could have a sheet of paper with all of these things. I am not going to know. Okay. If it's helpful, make sure you do that. Obviously, if you're going to take this in college, they are going to want you to be able to, if you have a trig function, integrate, find the derivative, all that kind of stuff. So just make sure that if that's in your plan still, that you're doing that. So use function notation if necessary, but the first thing I do is make sure I integrate. If you want to go and show the step of this is how it goes and looks, it has that, you can go and do that, but that is not necessary. Okay. So integrate, again, make sure you have a plus C. Then after you integrate, I'm going to plug in X and Y into that function. Okay. Then I'm going to solve for C. And then my last step is to plug C value in and make sure you have an equation. Okay. What that means is if I just write this, x to the third minus x squared plus 2x plus 1, that's not an equation. It needs a y equals. It needs an f of x equals. Okay, so make sure you go and do those things. So those are my pointers to help you go and write those integrals and find that c value. Just for some giggles here, if you go and look at some integration using some cows, if you have milk, where to start with? A cow. So I hope you appreciate that little bit of humor there. Hope you guys are doing great. Hopefully see you guys soon. Have a good one. Bye.